Afternoon, everyone. Can you hear me? Everybody get a robot? Don't leave without a robot. Dan's got those. My name's Ed Lasivic. I work in the sales team with Hitachi Data Systems. In case you're wondering what we do the infrastructure that makes all this stuff happen. We're here with our colleagues from Hitachi Consulting. They're able to help you make sense of all this stuff. And Pendaho, they're the guys that can make the nice dashboards and make everything make sense for you. Our next speakers are from Voci, and they're going to talk about using voice analytics to develop predictive analytics. And without any further ado, so I don't steal their thunder here, we're going to be talking with Anthony Gadient, President and CEO, and Lynwood E. Hines.
Thank you very much. So, as we just were introduced, we're going to talk about our experience working with a large company to use voice analytics to help them build a predictive churn model, which they've been able to determine is going to provide significant value for them. So we're a CMU spin-out. The genesis of the company was a collaboration between the computer science department at CMU, the HLT people in particular, and computer engineering. And they had a series of workshops looking at what they could do to sort of revolutionize or make revolutionary advance in human language technology. And the idea was application-specific programming hardware coupled together with the HLT algorithms. And that's kind of the foundational technology behind our company. So our mission is to basically extract actionable intelligence out of voice data. And so to do that, we, of course, are looking at what people are saying, but we're also able to determine the emotion that people are using. Certain physiological changes happen in your vocal tract when you get tense and so forth, and we can measure those changes. We can understand if it's a man or a woman speaking, what language or dialect is being spoken, and so forth. All of that information is useful for a variety of analytic purposes. In this particular case, it's being used to support the development of a predictive churn model. So the foundation of our company is this sort of next generation speech recognition technology that we've built a voice analytics capability on. By the nature of the technology that the company is founded on, we're really focused on enterprise scale problems where we're processing millions of hours of audio annually, converting it into machine readable form that can be subsequently analyzed. And the analysis that we're talking about here is all unstructured. So we're focused on unstructured analytics based upon that voice data. From a delivery perspective, we have two primary delivery mechanisms. The first is via a cloud implementation. The other is on-premise. For this particular case study, the implementation was on-premise at the customer site and using historical data. We also have an implementation that sort of works in real time, taking data, the voice data as it's being generated, converting it to a form that can be looked at, and so actions can actually be taken live real time during the course of a telephone conversation. One of the precepts underlying the company is the idea that we want to provide an open platform. There are other speech analytics companies that are out there, and one of the ways that we differentiate from them is by having an open platform that allows the data that we generate to be utilized by our analytics and also external analytics systems. So there are a number of text analytics systems that use the data we generate. In this particular case study, there was a combination of internal proprietary analytics that the company was bringing to bear, along with analytics from one of the companies that are listed up here. Unfortunately, we're kind of in the midst of a business negotiation with this company. Otherwise, We'd love to have them here and talk about their experience, and hopefully the next meeting we'll have consummated that deal and be able to include them in the conversation. They're a very large company. They have a very sophisticated data analytics team. And I think it's worth giving a little bit of a history behind sort of our interactions with this company and how we got here. So about 3 years ago, this company made a decision that they wanted to be able to closely monitor the sentiment of their client base. And to do that, the decision that they came to was that they were going to implement regular post-call surveys, where they used an IVR system to call out to customers that had some kind of a service call or had made a call into the contact center to find out what do they think about the experience. And the interaction was completely voice-based. The most important part of that interaction being kind of an open question of how do you feel about our company and what could we do better, what do you like that we're doing today. That information is basically analyzed on a very regular basis for sentiment and ultimately to produce what's called an NPS score, Net Promoter Score. And the reason this company is very focused on Net Promoter Score was they found a very high correlation between NPS and sort of customer perception of the company, and as a result, the willingness to continue to be a customer of the company. So an indirect measure of customer loyalty, if you will. So they went through a very elaborate evaluation process. About 13 speech analytics companies were looked at. We ended up winning that evaluation principally because of 3 things. First, the fact that we provided the highest accuracy output, which was very important for this particular result. And the fact that we produce an output that's very rich in meta information, in addition to the words, the sentiment behind the words, the emotion, and so forth. So we implemented that solution for them, and there was processing about 100,000 sort of calls a day that are generating these reports regularly, feeding into this department, which was a marketing group. And as they started to see the results and broadcast these results around the company, the question basically got asked, what could we do with this kind of data when it comes to churn? So when you think about churn, you're effectively dealing with the question of risk. What is the risk that my customer is likely to leave me? From a management perspective, a predictive model isn't what matters. What matters is how can I reduce churn? And that then sort of asks the question of what kind of insights are going to help me understand why people leave and what things can I actually change that will affect that behavior, either to stop churn in the future or to give them suggestions in terms of what the save model should be to effectively keep a customer that's likely to churn. So they have before starting this project, a churn modeling capability that they had spent years working on. And the data that had been used for developing that model had been predominantly structured data out of their CRM and other systems that they have. But it was, they did have some unstructured data in the form of chat sessions and emails. So the first thing that they started to do is do some experiments to include the data from these voice surveys. And that data was sufficiently interesting in terms of the results that it produced that it begged the question, what could we do if we looked at all of our, or not all of it, but a significant amount of voice of the customer data, i.e., actual conversations between the company and their clients. So the after-call surveys are an IVR system asking a question and an individual responding. What they were interested in is call center data, where it's a didactic conversation, and it's more complex from an analytic perspective, but a lot more information there too. One of these after-call surveys might last 30 seconds to a minute, whereas a call center conversation could be anywhere from 2 minutes to 10 minutes, even 15 minutes, depending upon the kind of problem that is being addressed. So we began to work with them to effect an implementation here to actually go about taking this data out of their call centers, converting it into a form that they could use within their predictive environment. A very important step in this process is, some of you may know that voice recognition is a noisy process. It's not like taking a chat session where you've got spelling errors and that sort of thing. You actually get misinterpretations of what people are saying. So one of the steps that you go through in using data like this is a filtering activity. And so as part of the environment that we've developed, we've got capabilities that allow us to have a very good understanding as to the likelihood that the result is accurate versus not accurate. So an ability to filter out noisy data so that you're using good data for the purposes of your analytics. So my colleague here, Mr. Hines, was actually led the implementation with this client, and he can talk to you a little bit about some of the challenges that we faced in actually implementing this to achieve these kind of results.
Sure. So yeah, as Dr. Gadient mentioned, this was a large company.
You may want to talk on the microphone there. Yeah.
Right, so this was a large company with a very complex infrastructure, and so we had some interesting challenges getting going with them. One of those challenges is that in order to move the needle on their churn prediction, you have to analyze quite a lot of data. In our case, it was necessary to analyze approximately 2 million customer interactions in order to produce a statistically significant number of transcripts that could be used for determining whether or not we were having a positive impact on their churn prediction. The calls were channel separated, so they were stereo with the agent on one channel, the customer on the other channel. We extracted emotion data and sentiment for each of the calls, as well as gender. And then this data was fed into their modeling system, and it went through a couple of stages into their system, natural language processing, as well as going into the machine learning portion of the churn model. And out of that process, saw a significant improvement in the predictive accuracy, and their conservative estimation of how much savings that would be generated by this implementing this system is $20 million.
So, Lynwood, from an implementation point of view, one of the things I think that challenges that we ran into was, one, they had a very diverse environment, internal versus external call centers, different recording environments, and it was imperative to match metadata together with the voice recordings. How do we go about dealing with those challenges?
We have approximately 90 different contact centers, and so we targeted 3 or 4 of the largest ones to do our analysis on. And what they did is they extracted calls from their Variant recording system, about 2 million of those, and they also extracted the metadata that they had collected for each of those calls, and they extracted those as XML files. So one of the challenges we found is that the audio was actually encoded in a way that's proprietary to Variant, so challenging to read that. So we were able to get around that problem and get that data converted into an open format that could drive our system. And then we married that metadata, that structured data that they get from their CTI system with that to produce a complete result that they could then take down to the next stage of analysis.
Actually, one of the things that we find when we work with companies in this kind of situations is because of legacy recording environments and so forth, it's necessary sometimes to tap into the phone system directly to be able to get audio. And so that's a course of action that we're working with a couple of large financial companies on to do similar kinds of efforts. But it's a challenge in that you're integrating directly with a very sensitive telephony system that is also highly complex. But on the other hand, it has the benefit that you don't have any compression on the audio. The audio is kind of right off the line. And once you've got that implementation in place, you're basically set up to be able to support real-time analytics. So as we look at kind of next steps, one of the things that we've observed and sort of discussed with our client is the fact that as you build an effective predictor, one of the things that you do is to change how you interact with your customer. So you're changing the customer experience. And because that customer experience is changing, you can't just assume it's done once. You have to really continually update this churn model to take into account the fact that you have a changing environment. And it's not sufficient to look at a subset of the data either, because if you really want to predict churn, it's really at an individual level that you want to be able to deal with it on. And that means you've got to evaluate all your data for all of your customers. So as we move to a complete implementation here, it's a pretty significant sort of engineering undertaking. But the kind of one of the very interesting things that our client is looking to do is, and this gets back to tapping into the phone system so that you're actually capturing the audio as it's occurring, is to take this churn data and use it to affect conversations that are happening in the moment. So ultimately, this is where we as a company are driving towards, is the ability to capture data, analyze it, turn it into a usable form, and then use that data to actually change how behaviors are occurring within a telephone conversation. So she says we only have about a minute left. Happy to take any questions anybody might have. Yes, sir.
So you're talking about a call center, but are you doing any kind of analysis of the data similar to like social media listings and applying that, doing printouts and looking at things that can be improved elsewhere across the enterprise?
So let's go back a couple slides here. So in this particular instance, the company that we were working with has a pretty sophisticated environment where they are using off-the-shelf solutions from different companies to take social media data from all the different sources. They put this data into a Hadoop environment, and then they marry it together with the voice data to provide a 360-degree customer view that is then used for the analytic purposes, in this case, predictive churn modeling.
Predictive system. It's just that it was somewhat data starved since it was missing all of the voice interactions they were having with their customers. And they have approximately 30 million hours worth of those conversations per year.
Yes, sir.
So as part of this exercise, it sounds a very exciting exercise. Are there any surprising insights that you found by analyzing the emotions on the voice?
Well, you know, we haven't done a principal component analysis. I think that would be really interesting to understand what is the benefit that's brought by emotion versus just the additional language, the additional words that are brought into the equation. I personally was surprised at the extent of the savings. You know, I thought we might see a couple $1 million worth of savings. When the client comes back to us and said, we estimate that we'll see about $20 million of savings annually, as a business person, I was very happy to see that, but I was surprised, frankly. And it's because of the increase in accuracy. You know, it's the fact that they can target much more effectively where they're going to spend time and money on customers, and then to have the knowledge to know what's going to make a difference is really crucial here. And that knowledge of knowing what matters is really captured through those interactions with customers, because you're able to understand what they care about from a sentiment perspective. Yes, sir.
Do the customers know they're being recorded, and if they do, does that affect the accuracy of
I'm 90% sure that like every call center I call into, they tell you your call is being recorded for quality control purposes. I can tell you, listening to some of that audio, people aren't reserved in what they're saying.
I've listened to hundreds of these calls as part of quality assurance and other parts of the process, and yeah, they're not reserved at all. And I think the thing is that every call center you call into, they tell you you're being recorded. I think people just ignore it anymore. It's just something that they expect.
Yes, sir.
So can the software adjust the call center employee's behavior to when it detects that the customer maybe anyway is not placated?
So today there's kind of two things that we are able to do. The easiest thing is to take a day or a week or whatever period you're interested in, look at all the calls for a particular agent and analyze those calls in terms of attributes like, did the call start out positive and then negative, in positive that started negative, did the calls run long or were they short, how much silence was there, did you interrupt the agent and so forth. So you can kind of come up with a score as to how does this agent can compare with somebody else and use that to improve agent performance over time. From a real-time perspective, we have an implementation that supports compliance, where in a regulated industry such as debt collection, and our friend from Duquesne isn't here anymore, you have very strict things what you can and can't say and what you have to tell the person that you're speaking to. And so the implementation there actually monitors the conversation to ensure you're saying what you're supposed to say when you say it. If you don't, you're reminded to say it. And if you're saying something you shouldn't say, or if the risk of the call basically is showing to become high because of emotion and so forth, it'll actually trigger an event that would go to a supervisor or a risk officer to be concerned about. Thank you very much.